So once again, we are all welcome to today's class. And then as the topic reads, what is the position of normalization in machine learning and data science modeling activities? This is part of our important clarification series. So with the team, always let the data speak. So we're getting several requests and also clarification regarding this point. I felt there's need for us to again make a video for it to clarify once and for all. What is normalization? We all know normalization. So whereby your data set need to be normalized. There are a couple of reasons. Sometimes you have several features. However, the unit of the feature may be different from each other. So in which case, one is in kg, kilogram, another one is in meters. So which means the values are going to be somehow not on the same unit. And you cannot ensure that always. Sometimes you don't even know the unit of some features. So therefore, normalization is a way of trying to reduce the effect of these different units of the features. Another reason sometimes why you might actually need normalization is sometimes you look at each of the column, that is each of the feature column. You see that in some columns you can have very small numbers, 0.2, 0.5, 0.6. Meanwhile, in the next column to it, you have so huge size numbers, like 10 billion, 2 billion. So, I mean, in order to make it easy for the modeling algorithm to be able to understand data properly, sometimes we need to normalize the data to certain range so that irrespective of the original value of those features, everyone will form into a particular range of value. Like you may want to normalize to between 0 and 1. So even billions of values will become just between 0 and 1. So by so doing, it is often believed that this could make life easy for the machine learning algorithm to be able to detect the intended pattern in such data set. However, it has been proven wrong time without numbers that going straight to normalization right from the beginning may actually be antithetical to the aim and objective of getting better results or accuracy or achieving better performance metrics. So in this sense, let us first of all start by again reminding ourselves of this machine learning modeling framework, which is an iterative process. So this is where you have working with data. Here you're working with data. So here, all the preprocessing you want to do will definitely be taking place here. Preprocessing, processing. Among them, you have normalization. Normalization. You normalize your data. Usually it takes place here. However, when are we supposed to do this normalization? So a couple of days ago, I was listening to a presentation of a research student whereby after collecting data set, the first thing was to normalize the data. They normalized the data, and I said, already comment, no, we are not supposed to do this. You see, let the data speak principle. Require us, let the data speak. Always remember this idea. It will go along with always guide us in taking the right decision, because taking the right decision is very, very important. This is why you always need expert, experienced machine learning engineer or data scientist to guide you in taking the right decision as you proceed in your modeling activities. So when you get the data set, irrespective of how you feel about the data, looking at it, the values of this data in each column are different. One is big, the other one is small. Or there are different units of each of these features, irrespective of the justification for normalization. The ideal thing is to always, first and foremost, let the original data, that data set in as much as there is no missing value that can prevent the algorithm from working. I can say among the pre-processing procedures, you see, in pre-processing, you may have to do, maybe you want to do the noise remover, remove noise. So you want to normalize. This is some of the pre-processing. So outlier treatment, emitting value treatment, and also other pre-processing activities. Among these pre-processing activities, apart from emitting value, that may be very important because there are a couple of algorithms that will not work if there is any missing value in your data set. So you need to fix the missing value. However, if you are looking at decision tree, for example, decision tree will still model your data even with missing value intact. So in that case, you can still run your first experiment using decision tree because it can allow you to model even while there's missing value. It means there is no really pre-processing activity that is absolutely compulsory. However, missing value may be one of the very important pre-processing that you may have to do because several algorithms will not work with missing values. So you have to first of all fix that. And then how do we treat missing value? We talk about that. Hopefully we have the opportunity to talk about it again in future in more details. Now, so today we are looking at normalization because I've gotten several questions and people asking, and I've seen people in practice making this mistake of directly normalizing the data. No. So you have to first of all have the original data set, the original data, then let it go in. Select the appropriate algorithm by starting from the simplest algorithm to complex one. Don't start with complex algorithm because you may miss the underlying pattern inside the data set. So once you run the experiment, check the performance measure, then go back. The first thing there is for you to do hyperparameter optimization. Very important. Without hyperparameter optimization, you cannot just decide that, okay, this algorithm is not performing. No, it's not allowed. So hyperparameter needs to be done. So once you are done with it, maybe you start with KNN, then check decision tree. Keep checking them until you are able to get one from simple to complex. Once you have been trying, nothing is working, then try support vector machine, then you may start thinking of other complicated algorithms, like maybe using ensemble method or hybrid. So, and sometimes after checking out the algorithms, even ensemble, you are not still able to get what you think you're supposed to have gotten. This is when you have to go back. Hyperparameter will make you go back here. Also, changing the algorithm will make you go back to the same place. You change the algorithm here. After you have exhausted the hyperparameter optimization and changing the algorithm, then you may have to go back to the data preparation stage. That is, at this point in time, then normalization can come in. Then you now normalize your data. See, when you normalize your data, then you start the process again, all over. Train, divide the data again, train and test the model, and then check the performance measure. Am I doing well? So you must have your result of the original data set as it came. And then you have the result of normalized data. You must have the two results side by side. This is how to carry out the ideal data modeling process. By so doing, you are on the safe side that you are not going to be able, you are going to be able to create a situation whereby you might miss important underlying pattern that is hidden within the data set you are modeling. And that is exactly what the idea of let the data speak is always all about. So when we talk about normalization, first within part of the data quality assurance. You want to make sure your data is the way it should be. Yeah. So you may want to check the accuracy of the data, timeliness, deliverability, interpretability. We look to this quality issue later on. However, among the major tasks in data preprocessing, as I've said, is you want to do data cleaning, data integration. Sometimes you have multiple files, you want to add them together, you want to merge them together, you want to do feature engineering, you want to convert one feature to make another feature, you want to add 2, 3 features, or sometimes you want to transform the data set entirely using some of the transformation methods. And data reduction activity also, you may want to also do that. Under data transformation, we may have discretization and denormalization. This is the one we are interested in today. So in this normalization, there are several types of normalization. So we say normalization is a very important data transformation process. The very popular one is the one referred to as min-max normalization, whereby you are going to specify what you want to be the minimum and the maximum of the new data. Let's say I have X1, this is the first feature, and then this X2, and this is the Y. So the first feature is all about 0.5, 0.7, 0.9, 0.76. These are the values under this first feature. But here you're having 26 million, 2 million point something. Here you're having 4 point something million. So you have big numbers there. So you see that, okay, I want my minimum to be min-max mean, okay, normalize the data into between 0 and 1. I don't want any of the data to be less than 0. I don't want them to be more than 1. Then it will normalize this to be every data set under this will be between 0 and 1. Everything else will be between 0 and 1. This is normalization. When you use the min-max normalization, it's a very common, very popular one. People often use it. However, there's nothing that also guaranteed, okay, which of the normalization method is the best. That's why sometimes investigating different normalization schemes may become necessary, actually. Even after using the one that is popular, maybe you started with this, you are not getting any improvement, you may have to go for Z-score. This one is going to normalize it by using this very simple formula. You have to calculate the mean and standard deviation of that particular column. And then based on that, then you use this formula. The new value will be the actual value before minus the mean divided by the standard deviation. So if you are converting this number, you end up converting it to this. In this case, there is no minimum or maximum value specified. No, this is called Z-score normalization. And then you have normalization by decimal scaling, in which case you just divide the value by 10 raised to the power 13 value, 10 raised to the power 1, divide everything by 10, divide everything by 1,000, by 10,000, depending on the number of J, 10 raised to the power J. This is normalization by decimal scaling. So which one will work for you depends on your data set. Again, let the data speak. However, you can start with the very common one. Like I said, this is one of the very common normalization scheme. But then if you have the time and the opportunity, it's always good to also check other normalization scheme. Perhaps this will make it possible for your algorithm to be able to understand the hidden pattern in your data set. Because the essence of all this is that we want to be able to get what is inside the data. So that's why even in normalization, you may have to try. And that's why data science processes are actually encouraged to be carried out in a team. Because sometimes there are so many things you need to check. Check this option. Which option is better in normalization? Check min-max, Z-score, normalization by decimal scaling. So you can distribute the task. One of the team members is working on min-max, another one is working on Z-score, another one is working on the decimal scaling. So your result will quickly be out. You can compare it. Which one is giving us better result? I think this one is working better. Then we are going to adopt Z-score. Then you move on to the next stage. So there are so many activities that are involved in data science processes. So that's why it's highly recommended that projects be carried out in a team. And minimum recommended is between 4, 5, and above. You see, to be able to do something really rigorous. But if you are doing it alone, then you must be ready to subject yourself to some of these several options that you have to try. Otherwise, you may be making wrong conclusions that this data is not good. You need to go and look for another data. Meanwhile, you have not been able to exhaust all the possible opportunities and options that may give you better results. So when you have tried any of these options, then, like I said, you have to put your results side by side. So you now consider, where is my result of the original data set? Where's the result of normalized data? Normalized data. You have the result now. You put them side by side. Then you see which one is giving better result. If the original data set is giving you better result, then it means subsequently, whatever you want to do later, you can continue to work with the original data set. See? So what we've often noticed people doing is, the moment they get the data set, they normalize it. And they are working with normalized data right from the beginning. This is a wrong procedure to take. Because we have seen in real life practical example whereby the original data set without normalization gave the best result. So if you normalize it and you throw away the original data, then permanently you prevented yourself from achieving the best result possible. Then you'll be saying that it is the algorithm that is not able to understand the data set. You can see that it's not the algorithm, but you, as the data scientist or machine learning engineer, you are the one that have refused to allow the system to work. And why? Because you have not allowed the data to speak. So always think about this. Let the data speak. Before you, no matter how people speak much about something, oh, this normalization scheme is a new one, it's always good. There is no process that is always good for every data set. So you have to check. A normalization scheme may be good for your data A, produced using the same procedure. Another data B, it may not work for you, because it depends on which kind of information that is hidden within this data set that you are using. So this is a very, very important process that I want us to take note. I've continued to see a lot of mistakes people do make related to the issue of normalization. It's a very interesting idea. It can perform wonder in your data set modeling, but that is when or after you've tried the original data and you are not able to make headway. So always give room for your normal data set, the original one, to do its work first. It is when it is not working, you are not able to get the expected, or everybody expects to get, is always hoping to get the best result possible. But then you may not be able to get it. This is when you have to start going back. And that's why the system is very flexible for you. It's an iterative process. You can always go back. So there's no need to be desperate. You must get it at once. You see, if you read all the literatures, this is the best way. Once you get your data, you check this data. If it's like this, some data are big, some are small, then you have to normalize the data. It's not fixed. So let the data speak. Run the experiment on original data first and foremost. See, the moment you are reporting the outcome of your work, even as a researcher, we notice that you are only reporting the result of your normalized data. The question that comes to the reviewer's mind is, where is the result of the original data? Always put this at the back of your mind, please, and you don't forget. So run the original data set, record the result. It is the result that will actually tell you if there's need for you to proceed to normalization or not, or any other pre-processing method. You see? So let us pay attention to this. Otherwise, we'll be wasting time carrying out experiments that are not necessary. And at the end of the day, we might end up missing important pattern that the data originally actually contains. And which algorithm can we use together with the normalization? There's no one that can tell you this. There'll be a lot of theoretical basis, but always come back to remember what we tell us. Let the data speak. Comparative analysis is highly recommended. Run it on original data set, see what you can get, then normalize the data, check the result again, then try to also normalize using another method of normalization if you are not yet getting the best. However, if you have run the original data set right from the slide, you are getting 99 or even 100% accuracy, confusion matrix, everything is superb, everything is excellent, then there's no need to then say, okay, I must run normalization. No. You see? So if you must run normalization, that's fine, but do that after this, and you'll be surprised that when you run normalize data, you might end up getting like 85%. And this is what we have also detected from experience. Where students decide to normalize data, but they struggle to get good results. After that, they brought the issue to my table, and I look at it and ask questions. Where is the outcome of the original data modeling? They said we didn't do it because we just went for the normalization because we read it somewhere that normalization always produces. I said, no, it is wrong. Go back, use the original data, and surprisingly, they got the best result using the original data that came to them. So this is what we say we have to avoid such mistake. So by always letting the data speak. Therefore, the position of normalization has to answer the question we started with at the beginning of this lecture, which is what is the position of normalization in ML and data science modeling activity? It is that has to be considered at the stage of iteration. The first and base is for you to run the experiment on the original data set, the data set you came with, and then based on the result, then you can now go back iteratively and then try to normalize the data and then see what improvement it can actually provide. And you may also have to try few or different type of normalization procedure that is possible. So I believe this is the clarification we'd like to make in this, our clarification series, based on the principle of letting the data speak always. Thank you very much for listening.